Sorry, it is a very interesting time for this streaming stuff. I'm a little person down there in the corner, at least for the people on YouTube. As I was saying, because we have physical people here walking around, because it would be a kind of task for me to design or to cut all the designs I'm getting from you people, but we have people walking here who can do this, which means that we are a bit more able to realize your designs, so we are not that limited. I wanted to quickly talk about some materials that we have here. I can show you some materials. At least I think I can, yes. It was just under the desk hiding from me. Because laser cutters, and I'll talk more about this tonight, laser cutters have a variety of materials they can use. And for instance, we have this material. This is acrylic, 3 mm thick acrylic. And the blue sheen you see over it is just a protective film. It's actually transparent, which I can show you. I made a small case for a Raspberry Pi camera. So it houses a camera, so you can see it's pure and clear acrylic. That's very cuttable and also engravable. And I'll show you more about how to engrave and what it looks like tonight. Then we also have some cardboard. And cardboard is nice because it's quite, well, I think it's quite pretty actually, but it's also very manual. So it's the cutter has no trouble at all going through it, and it's really quick to cut because it's basically a lot of air in there, and it's super cuttable. So the speed is there. So it's like if you would cut the design in wood and it would take 10 minutes, the same design would take only 1 minute in cardboard because it's such a more easyable and more laser cuttable material. I also have really thin cardboard. I've used this before to cut out cardboard boxes and make presents for people. We also have some actual paper stuff. So this is quite flexible paper, which is nice because you can actually go 3D with your sheet. So you can have some more options creative-wise, basically. There is also wood. I don't recommend wood for cutting because it takes quite some time. The speed it uses to cut through is just very low. But we can use wood to engrave on. So if you have an interesting engraving idea, and I'll have some examples for that tonight, then I have also some nice plywood laying around that I can cut and then have engraved with your design, basically. I will now kind of go through a small list of what can you make, but it might be nicer that maybe someone already has a question about something or that has been on their mind since they signed up for this workshop, and that we should start discussing stuff. Is there anyone who would like to ask something or share an idea they have?
I would like to ask a question
Yes?
about my design. So I was hoping to make a hexagon and kind of like an art mobile, have little pieces of hexagon that could like be hanging inside of it with a string that I'll get later.
Yeah.
And I'm just wondering, how difficult are we allowed to get with our designs before you'll be upset with us?
Well, the design part you can get really complex with it. If you're able to make a complex design yourself, that's great, and I would really encourage you to do this. It's just if we actually have to then assemble your design, and that takes like 2 hours just to get all the intricate wires there, it will be a bit more difficult. And so I think it would be good that
Okay.
if you have designs and you have already rough sketches of this, just start sharing them so I can early on already give you some feedback on how feasible it is, basically. But it sounds very cool. Sounds like an interesting
Okay.
abstract, minimalistic, mobile idea. So it sounds very nice. And maybe you can convince one of the students who are physically present here that they can assemble your design, basically. So that's also a possibility.
Okay.
Yeah.
I
Thank
don't
you.
know anyone there. I don't
Oh
I
yeah,
don't
but
know
then
anyone there. I'll have to try to start sweet talking
yeah,
everybody.
yeah, but I'll also then yeah put in a good word for you and show the design. So maybe someone is really interested in. Oh yeah, I want to
Okay,
assemble
thank
this.
you.
Yeah, thank you for your input. Is there anyone else? Otherwise, I'll start showing you some
Okay.
quick examples. All right. Well, what I think I'll do, because when we got these questions from students and participants, like, oh, what can we make? And that is an interesting question when you're talking about a laser cutter. Um, because you are, on the one hand, limited to the functionality of the device. On the other hand, you can use your creativity to kind of surpass this. So I will share my screen. Yes, share my content. Okay, very good. Can everyone see my screen? Yes, I'm getting a thumbs up from the audience here. That's good. Okay, so I will show you this. This is my own archive of the stuff I've been making the last couple of months, and I used the laser cutter quite practically, and you can make quite some stuff with it. So, for instance, what is one of the earlier things I made? I think that's this one. Yeah, this is a very. I had a problem and I had to fix it. We were building a new garage, and in that garage we have this new electricity box. And electricity boxes have these standardized railings where you put like fuses on and breakout boxes. And I had this old Apple airport, which I wanted to use to get some internet into it and route through the internet, and also create a Wi-Fi spot. But I wanted to get that thing into that electricity box, so to use it on the to click it on there. So this is one of the first things I designed really quickly to have a practical purpose. So just measuring the device, and in the Fusion 360, I can see here that blue thing is actually something I bought because that clicks onto the rail, but it has two screws. And then it just all clicks together, and in the end you can see that it's a little holder. So this is a very practical thing, so you can maybe look around at home to see, oh, this might be improved, or this is a nice way to hang some keys or do something. So this was one of the earlier things I made. Then at some point we got this 360 camera, and it has a mode where both the lenses turn forward, so it becomes stereoscopical. But when you make a picture with it, the way that's ergonomically designed to the camera, it means that your thumb is always really ugly in the picture. So every picture has a big fat thumb in the photo. So I designed this little holder with a spring installation, so you can have this trigger functionality, and it clicks the button on the left. And I must be honest, it doesn't work because, of course, you're using wood, and wood bends, and it's trying to push a button that's made of hardcore, super nicely cast plastics. So, in principle, it works perfectly, but of course, it needs an iteration. But you can see how you can solve problems with it. Then let's see. Oh yes, we bought a bunch of avocados because we're healthy hipster people, and then we had these pits, and you can grow them. So I got this acrylic sheet and really nicely cut up some holes, so we can have a little avocado growing section in the windowsill. So that's all. Again, it has tiny legs. You can see here on the bottom I used a plastic glue, which kind of, yeah, it's not pretty for acrylic. We need different kinds of glue. I learned a lot from this experience because this glue I used kind of damages and creates a bit of an ugly outline onto the plastic because it just basically bites into the plastic. So there is that. And then at some point, well, I told you I had that Raspberry Pi, and we bought a high quality camera module for it for time-lapse purposes, but we were using a piece of cardboard to make the time lapses, and I thought, no, I need this device, I need a box for it. So like you can see here, the Raspberry is mounted on the inside, and it has a little door and an actual hinge. It uses some glue, but the hinge is rotating, so you can close up the box, and you can access the computer inside. Which is also very interesting to do this because then you need to get some technical drawings or specifications of the hardware that you're using and build around it. So that's something very possible. Well, and this one is quite current. I got this e-ink display, and an e-ink display is a very fragile piece of electronics. You can see it here. So it's basically the e-ink displays are the ones you use for e-ink readers. So they're very low-powered grayscale displays, and they come with this naked piece of electronics, and it's on a piece of glass. So the manufacturer even warns you, like, hey, when you use this and you don't have a case for it, please stick it down on a piece of cardboard so you don't damage it. So I decided to make a little display for it, and I had to use both cardboard and wood. And I also needed to have a place for my electronics, in this case an Arduino and a Raspberry Pi, to be able to interface with the display. So you can see all the parts here, the stuff that was made, and it took an hour or two, three to design this. It's a lot of measuring and see if it works. And then in the end you can see it slowly coming together. So I'm hiding away part of the electronics. So in here you can see the electronics being bent around the corner, otherwise the laser cutter can only cut up to an A4 size, so 30 by 20 centimeters. And I realized in my first design I made it too big, so I wasn't able to cut it with my device. So I had to be creative and fold this piece of flexible PCB basically around the corner. And well, in the end, I think it looks quite nice. It has a little stand, and it's very stable, and I can interface with it. So this is just a way to show you very practical ideas of laser cutting. But if you Google for what is a laser cutting project, what you get is something like this. So they start talking about clocks, which is nice, and this is a very nicely intricate way of making something with a laser cutter. And here especially you can see a lot of engraving, so the darker parts are where the laser cutter was burning the wood but didn't cut through, so the speed was a bit higher and the power maybe a bit lower. So you can see it burned away some of the wood, so you get this burnt look. And there's clocks for a while, and then at some point it starts to change in something else, which is nice because clocks are okay, but maybe you can make something else than a clock. Here they start to make basically little gifts for people, like these are coasters that have been burnt in. And this is really what you get in the beginning if you start looking for inspiration for laser cutting projects. You get little gifts for your family, which is nice. And it's a good first step to get to know the machine and its capabilities, but at some point I kind of want to encourage everyone to make something more three-dimensional maybe, which is kind of weird because you're working with a two-dimensional machine, but that making something three-dimensional is a bit of a challenge. But I can go through this. These are all wood-based stuff, at least most of them, and it's a lot of cutting or, well, this one is actually made of, I think it's some filled stuff, so you can, that's the nice thing about a laser cutter. I mean, it's just a high-powered laser, so you can even engrave glass. So if you find a nice piece of glass somewhere and it fits in the laser cutter, then you can engrave glass, you know, and you can even engrave leather, you can engrave metals. So it's quite versatile in that way. So even here you can see it's some kind of fabric. It might be a fake leather, it might be a real leather. I am uncertain. Here we get paper art. I'm also very interested in paper art because there's something, it really highlights the precision of the cutter. The cutter has a reported resolution of 1,000 dots per inch, so you can get really intricate with it. So you can even cut out these kind of beautifully pre-made origami figures. And like here they made a map of a city, inverted it and showed all the roads. And you get this typography art. This one is also nice. This is like, well, 20 different layers of cut out, really thin, I guess, a kind of hard paper, and put on top of each other to create this 3D effect with some light in the back, which is interesting. You might even think about having this move if you want to make it even more interesting. So there's a lot of different ideas. Some are a bit more original than others, in my own opinion. I mean, this is nice because of the size. You know, it's quite impressive that it hangs there, but in the end, it's just an image cut out. Here again, you get this really intricate wooden designs, and especially this one. This is just, well, I don't want to think about the gluing process to make this because it's interesting and also time-consuming. So yeah, this is just when I googled, the first thing that came in my result, the 150 amazing laser cutter ideas. Here you get some jewelry or some earrings perhaps, if you make them small enough without people earlobes being pulled apart. So these are some of the ideas. So if you're still wondering what can you make, what is out there, I implore you to just Google. And one of the other things I wanted to show you is it's a bit of an add-on for the program I'm going to use tonight, and there should be also some open source versions of this. But the laser cutter makes a flat two-dimensional thing. And a 3D printer, which was explained yesterday by Christianis, is a laser cutter basically is a primitive 3D printer because and the only thing a 3D printer has more is the Z axis, and it just makes a layer and then is able to add another layer on top of that. So what you can do with a slicer like this, you can have an image. Maybe I can see where they show both of them. There's this really nice software that if you are really well versatile in Blender or any other like actual 3D modeling software, you can use this program and it takes your actual mesh, your 3D model, and it turns it into different slices. And you are very much, it allows you to change a lot of parameters in the program. So you can make it as hollow as you want, for instance. Um, and you can have it, because in this case it's horizontal and vertical, the slices that are interlocking. And on the right side it will also show you the parts you will need. So you can set your workspace to A4 paper and it will show, well, then you have this amount of slices needed, and it will take this amount of plates, so this material will be needed. So this is also very interesting to work with, because here it's actually just vertical and horizontal, but you can make them diagonal, and that really creates a different feeling of the end result. So someone here made a horse or something. Yeah, it looks like a horse. And you can actually get just a 3D printed version of something, but this time, here it's just layers, so the resolution is way lower than an actual 3D printer. But still it creates some interesting results. Like here, this is, I'm guessing, Yoda, maybe. But because it's the resolution is so low, it creates a really skeletal figure of it. So I came across this. I've worked with it a couple of times. I just printed out some heads and stacked them to see how it works. And it's an interesting thing. The only thing I have to add to this, it works on Windows, which means that if you have your model and you don't have a Windows machine, you can just send me the file. And I have a Windows computer here, or maybe one of the students. I see that not everyone has a MacBook, which is very good. So it's a Windows only program, at least the one I found. There might be some others out there. Okay, maybe I should go back to the teams, and I'll quickly tell the people that have just walked in. There's also people in Teams listening to this, and they will be participating in a workshop online. So they might be designing stuff at home, contacting us through Teams, and I will instruct the people who are all here how to use the laser cutter that's here, so that, because I might be busy with some other stuff, that the designs made by the people who are joining us online are also able to be cut, and maybe some of the students here will be able to cut those stuff, which is good exercise to get to know this little laser cutter. Is there anyone in the teams who now has a question for me, or some remark, or just wants to spout out an idea?
Yes.
Yes.
Very good, very good. Okay, I guess we'll take a small moment now to discuss what people are thinking of and what we can focus on. And I would kind of like to get a head count on how many people will design something that we can cut here, because it's busy times, and I would like to get a bit of a schedule going, because I see in this Teams there's 1, 2, 3, 4, 5 people here, and do all 5 of you want to have something, design something and let us assemble something for you, or is there someone who says you're just here to create and design something, but it is fine if it doesn't get cut immediately?
I'm okay if mine doesn't get designed, but I'm also happy to send something to be designed. It's fine for me either way.
Okay, okay. We got a question from Magda about the balsa wood. And
I actually have a question.
yes,
But prior I was asking about balsa, but I found out that I don't have enough to make anything with it. And so my other question would be if cork would be a possibility.
Yes, cork. I haven't used cork myself, but I have read a lot, and especially in the manuals for this particular color, that cork is also recommended as a material. It depends on if you want to just do engraving or if you want to also cut the cork.
Oh, I
Uh,
was thinking more about cutting.
okay, and then we need to check how thick the cork is.
Uh, I think it's somewhere between 3 and 4 millimeters.
Okay, well that's I think within the range, because cork is quite a soft material, relatively speaking. But are you in Liepaja?
Yes, yes.
Okay, so maybe you can even come by tomorrow.
Yeah, yeah.
Okay, because then I would say work on your design, and you can come by tomorrow and we'll need to use a small part of your material to do a cutting test. I'll talk more about those
Mm-hmm.
testing ways in the next actual lecture. But it will just determine what settings we need to use, if any, if we can cut through your material without burning it or without scorching it. Maybe we need to mask it off. Is it nice and flat? Those are the things we need to
Uh,
find out.
there is a slight problem that one side of it is has a texture on it.
Okay. Yeah, and the texture is just like a textile texture, or what kind of stuff is it?
No, no, no. It's like one of those decorative um ones that have it's hard to describe. It has a pattern on it, but
And
it's
it,
still cork.
okay, so it's okay. It's a cork-based pattern then. Well, then yes, we just I would just implore you to come here tomorrow, and we can test your material, which is fun to do, because it might work perfectly, that it cuts very cleanly. We might need to up the power of the machine to get really through it, but it's always interesting and learn a good experience to have. So I'm guessing that most of you who are not familiar with Fusion 360 or other CAD programs might be more familiar with Illustrator, for instance. And seeing how Illustrator is a vector-based design program, and laser cutting uses vector graphics to guide the laser around, you can really use Illustrator 2 to engrave and cut. Um, I will just tell you that colors don't matter in Illustrator, not for the laser cutting. You should save the file as an SVG file, um, preferably SVG 1.0. There's also a 1.1 version, but it's sometimes gives a bit of well, these laser programs they are used to the 1.0 version, and there might be some compatibility. Usually there isn't, but I would just recommend use 1.0. And what you should do is make two layers. If you want to engrave and cut, separate those, because we can take your SVG files and it has those layer information, and in the program we're using to actually control the laser cutter, when you import the SVG, you can import the layers separately. So then you can really assign a layer to a different machine setting. And as I told you, well, we need to really make the machine behave differently per layer. So engraving is faster but lower power, and cutting is very slow but higher power. So when you make a cutting line, it's really just a closed line in Illustrator, and it doesn't have any infill. So it can have just a black color as a stroke, but the infill is not there. And if you want to engrave something, then just use black. And as I told you, if you're going to engrave wood, wood can really be engraved in grayscale. So you can even do like a linear infill from black to white, you know, those linear gradients. And you'll see that back in your actually engraving. So if you want to start designing stuff, but well, you just don't know Fusion 360, you can start in Illustrator. It's not a bad idea. I use Illustrator all the time in combination with Fusion 360, because Fusion 360 is good for the 3D design, but then when you want to lay out your plans and work in 2D because you have your two-dimensional designs already, then you can use Illustrator because it's just well, and I guess as an open source counterpart, you can have Inkscape. I've never been the biggest fan, but maybe that's my own ignorance, and I've been spoiled by the UI of Illustrator. But the Inkscape is also widely used in this field. So yeah, so if you don't have Fusion, or you don't or find it a bit daunting, or you just want to create a 2D design that you can easily make in Fusion or in Illustrator, please use that. Um, I think if there's anyone physically in this room, one of the students who has a question, I know that there's already some people who have some tests they want to do. I will do those tests, I think, at the end of the lecture between 5 and 7. I have my own little plan laid out, but I think I have some time to also make something that one of the students here makes. And that will be also interesting to see.
I sent you an email because I can't send you a message in the chat. So when you have a chance, check the email. There's no big rush or
Yeah,
anything.
I can do that now. It will be interesting to discuss. Is it okay if I share the screen with your image?
Yeah, you can share my horrible drawing abilities with everyone if you
Ah,
like.
this is beautiful. I will share the screen. Let's see here. Okay, you can see my screen, I think.
Yeah.
Okay, and you were talking about those hexagonal shapes, right? And then suspended
Yes, I just
between.
couldn't draw them.
Oh, that's what I do. Just they're just the objects. It's fine. And you want to suspend them between like wire, I guess.
Yeah, so like the outer shape is supposed to be a hexagon and it would be three-dimensional. It would have enough depth for the shape to be able to stand up by itself on a table. And
Okay.
then yeah, there would be like a nylon thread that would
Yeah.
connect all of the smaller hexagons.
With like little knots, so the hexagons don't shift through over the nylon, I guess.
Yes.
Okay. Well,
Yeah. Sure.
one remark already for me, you're talking about the frame standing up by itself. That would mean that
Uh-huh.
the frame has some depth to it. I'm guessing, well,
Yeah.
this really is limited to 3 millimeters. So I think that's too little to let it stand, but we can easily create really low profile feet on the left and right that click in. And then you can
Okay.
have it, then you can have
Okay.
it stand and not be like giant feet,
Okay, that's fine. Okay, no, so in my
what is it?
email, I kind of described what I had intended, which was maybe to have it be a hexagon made from several rectangles that would be glued together, but it doesn't have to be that complicated. Your solution sounds good.
Okay, no, that's up to you how you want to make the actual hexagons, and yeah, it's quite fine, I think.
So the other thing I said in my email is that I didn't want to kill anyone with the fumes. So maybe it's
Oh,
too
in that
many
sense.
shapes to make out.
No, no, that's fine. If we get good ventilation, then we really have it next to a window here, and it has a quite a powerful ventilator built in, so that should be okay.
Okay.
And yeah, no, and acrylic really is beautiful for this because it really does reflect, and especially the acrylic that we're using here is really well suited for laser cutting. So the finish on the edges, I can stop showing my screen, but go back to my webcam. You can see me again, I think. Like this is
Yes.
the back sheet of that acrylic, and not sure how visible it is, but it's really transparent. So this is a cut
Yeah.
piece here, and you don't have those white marks that you might get from other types of acrylic. The only thing you see is that I use some glue. So and the glue was a bit of a wrong choice I found out later. But I'm not sure if you can see
Okay.
that here, but the side is really nicely, it's flame polished, I think they're calling it. So yeah, no, I would recommend that making it from acrylic.
Okay.
Yeah, and we can just talk about how we're gonna make it stand up, so it doesn't fall over. Yeah,
Okay. Okay.
excellent.
Thank you.
Yes, yes, you're welcome.